Introduction. The dinner is quite delicious and I'm enjoying it very well.
Yes, Dad. I agree with you. I'm also enjoying the dinner.
Son, please pass me the salt.
Sure, Dad.
Son, will you answer my one question?
Yes, Dad. I will try to.
Okay, so tell me, why the sugar and salt particles have different structures?
Maybe due to different constituent particles?
Son, your answer is right but not appropriate. I will tell you. Every structure depends upon the nature of chemical bonding between them. In sugar, there is covalent bonding in the molecules, whereas in salt, there is ionic bonding in the molecules.
Okay, Father. I got the reason and I want to know some more about that.
Students, today we will study more about the chemical bonding and molecular structure. Objectives. At the end of this lesson, you will be able to define chemical bonding, understand octet rule and Lewis symbols, define ionic bond, know about the factors affecting the ionic bond, explain properties of ionic compounds, define bond parameters, describe resonance structure, know about polarity of bonds. Definition. Most of the substances in nature exist in the form of molecules, which are the cluster of atoms of same or different kinds. The attractive force which holds various constituents together in different chemical species is called chemical bond. The chemical bonds can be classified into various types like ionic bond, covalent bond, coordinate bond, metallic bond, hydrogen bond, and van der Waals forces. Coastal-Lewis approach to chemical bonding. The developments in the field of atomic structure provided foundations for various theories of valency. The initial contributions in this field came from W. Coastal and G. N. Lewis in 1916. They were the first to provide some logical explanation of valency, which was based on the inertness of noble gases. Octet rule. The rule states that atoms of various elements enter into chemical combination so as to attain the configuration of 8 electrons in their outermost shell. They do so either by transference of electrons or by mutual sharing of electrons. Lewis symbols. According to these notations, the symbol of the element represents the nucleus as well as the electrons in the inner shells. The electrons in the outer shell are represented by dots surrounding the symbol. The number of dots represent the number of valence electrons. The common valencies of the element can be calculated from the valence electrons. The common valency of the element is either equal to the number of dots or 8 minus the number of dots. For example, the common valencies of lithium, beryllium, boron and carbon are 1, 2, 3 and 4 respectively, while those of nitrogen, oxygen, fluorine and neon are 8 minus number of dots, that is 3, 2, 1 and 0 respectively. Example on Lewis symbols. Let's take an example on Lewis symbols. Use Lewis electron dot symbols to represent the transfer of electrons from magnesium to fluorine atoms to form ions with noble gas configuration. Let's see the solution. The Lewis symbols for the atoms are: the Mg atom loses 2 electrons to attain a noble gas configuration, but F atom can accept only 1 electron to fill its valency shell, so 2 F atoms must take part in electron transfer. We can represent this electron transfer as ionic bond. Ionic bond is formed by the transference of one or more electrons from one atom to the other. Generally, this type of bond comes into existence between a metal and a non-metal atom. The metallic atom loses its valency electrons and changes into a positive ion called cation, while a non-metallic atom gains electrons and gets converted into negative ion called anion. The oppositely charged ions are held together by electrostatic force of attraction. Ionic bond may be defined as the electrostatic force of attraction holding the oppositely charged ions. Energy changes during the formation of ionic bond. The formation of ionic bond proceeds in following 3 steps. Step 1. Formation of gaseous cation. The energy required for this step is called ionization energy. Step 2. Formation of gaseous anion. The energy released from this step is called electron affinity. Step 3. Packing of ions of opposite charges to form ionic solid. The energy released in this step is called lattice energy. Now, for stable ionic bonding, the total energy released should be more than the energy required. The conditions for the stable ionic bonding are: ionization energy of cation forming atom should be low. Electron affinity of anion forming atom should be high. Lattice energy should be high. Differences between ionic bond and covalent bond. Ionic bond is formed by transference of electron from one atom to another, whereas covalent bond is formed by mutual sharing of electrons between the atoms. Ionic bond usually exists between metal and non-metal atoms, whereas covalent bond usually exists between non-metal atoms. Ionic bond is non-directional, whereas covalent bond has directional character. Ionic bond is always polar, whereas covalent bond may or may not be polar. Ionic bond holds charged particles of opposite charges, whereas covalent bond holds neutral particles. No multiplicity is observed in ionic bond, whereas covalent bond can be single, double or triple bond. Factors affecting the ionic bond. The factors which favor the formation of ionic bond and also determine its strength are following. Ionization energy. In the formation of ionic bond, a metal atom loses electron to form cation. This process requires energy equal to the ionization energy. Lesser the value of ionization energy, greater is the tendency of atom to form cation. Electron affinity. It is the energy released when gaseous atom accepts electron to form a negative ion. Thus, the value of electron affinity gives the tendency of an atom to form an ion. Greater the value of electron affinity, more is the tendency of an atom to form an ion. Lattice energy. Once the gaseous ions are formed, the ions of opposite charges come close together and pack up three-dimensionally in a definite geometric pattern to form ionic crystal. This process is accompanied with the release of energy referred to as lattice energy. Thus, lattice energy is defined as the amount of energy released when 1 mole of ionic solid is formed by the close packing of gaseous ions. The magnitude of lattice energy depends upon the following factors. Size of the ions. Smaller the size of ions, lesser is the internuclear distance and greater will be the interionic attraction. Hence, larger will be the magnitude of lattice energy. Charge on the ions. Larger the magnitude of charge on the ions, greater will be the attractive force and higher is the value of lattice energy. Properties of ionic compounds. The common properties of ionic compounds are following. They are bad conductors of electricity in solid state, but are good conductors of electricity in molten or dissolved state. The chemical reactions between the ionic compounds involve the combination between the ions furnished in the aqueous solutions. Such reactions are called ionic reactions. Generally, ionic compounds exist in the form of crystalline solids. They have high melting and boiling points. It is due to very strong electrostatic force of attraction between oppositely charged ions. They are soluble in water and other polar solvents which have high dielectric constants. They are insoluble in non-polar solvents. Bond length and bond angle. Bond length. It is defined as the equilibrium distance between the nuclei of two bonded atoms in a molecule. The covalent radius is measured approximately as the radius of an atom's core which is in contact with the core of an adjacent atom in a bonded situation. The van der Waals radius represents the overall size of the atom, which includes its valency shell in a non-bonded situation. Bond angle. It is defined as the angle between the orbitals containing bonding electron pairs around the central atom in a molecule ion. Bond angle is expressed in degree. Bond enthalpy and bond order. Bond enthalpy. It is defined as the amount of energy required to break 1 mole of bonds of a particular type between two atoms in a gaseous state. The unit of bond enthalpy is kilojoule per mole. Bond order. The bond order is given by the number of bonds between the two atoms in a molecule. With increase in bond order, bond enthalpy increases and bond length decreases. Resonance structure. According to the concept of resonance, whenever a single Lewis structure cannot describe a molecule accurately, a number of structures with similar energy, positions of nuclei, bonding and non-bonding pairs of electrons are taken as the canonical structure of the hybrid which describes the molecule accurately. When a molecule can be represented by more than one Lewis formulae, none of which is able to explain all the observed properties of the compound, then the actual structure of the molecule is intermediate of the various Lewis formulae and is called resonance hybrid. Polarity of bonds. In ionic bond, the cation tends to polarize the electron cloud of the anion by pulling electron density towards itself. This causes development of covalent character in ionic bond. Smaller the cation, higher is its polarizing power. Cations with pseudo-noble gas configuration have relatively high polarizing power than those with noble gas configuration. Larger the size of an ion, higher is its polarizability. Difference between metallic bond and covalent bond. The simultaneous force of attraction between the mobile electrons and the positive kernels constitutes a metallic bond, whereas the mutual sharing of electrons between the combining atoms of the same or different elements is called a covalent bond. Metallic bond is a non-directional, whereas covalent bond is directional. Metallic bond is a weak bond because mobile electrons are simultaneously attracted by a large number of kernels, whereas covalent bond is a strong bond because the bonded electron pair is strongly attracted by two nuclei. Did you know? In metallic bonds, huge number of atoms lose their electrons. They are held together in a lattice by the attraction between free electrons and positive nuclei. The difference of energy between the resonance hybrid and the most stable resonating form is called resonance energy. Pure ionic bonding is not known to exist. All ionic compounds have a degree of covalent bonding. Summary. Let us summarize what we have learned. The attractive force which holds various constituents together in different chemical species is called chemical bond. Octet rule states that atoms of various elements enter into chemical combination so as to attain the configuration of 8 electrons in their outermost shell. In Lewis symbol notations, the symbol of the elements represents the nucleus as well as the electrons in the inner shells. The electrons in the outer shell are represented by the dots surrounding the symbol. Ionic bond may be defined as the electrostatic force of attraction holding the oppositely charged ions. Electron affinity is the energy released when gaseous atom accepts electron to form a negative ion. Lattice energy is defined as the amount of energy released when 1 mole of ionic solid is formed by the close packing of gaseous ion. Bond angle is defined as the angle between the orbitals containing bonding electron pairs around the central atom in a molecule ion. Bond angle is expressed in degree. Bond enthalpy is defined as the amount of energy required to break 1 mole of bonds of a particular type between two atoms in a gaseous state.